We're going to be looking at an example, an approach of solving a problem that would be, in my opinion, a typical test or exam type of question. And let's just have a look at how you would go about solving it. Now, essentially, up to this point, the command that we've covered is what I think essential, and I think it's all that really needs to be, or is really needed for you to be able to solve pretty much any engineering or scientific problem. We will be looking at graphs and plotting them in the next video. But other than that, we know the basic essentials to pretty much attempt any type of problem. So with this, we're going to be looking at the basically 2 program that you have to do. So in other words, what you want to do is you want to enter in some decimal number and you must convert it into a base 32 number. Okay, now base 32 number is something we haven't seen before, it's something we're not really familiar with, but we are familiar with the base 16 number system. So base 16, let's have a look at that and take it from there. So let's look at an example of, let's say, the number 216. So this is base 16 and we want to, this is base 10 and we want to convert it into a base 16 number. How would we go about doing that? Okay, so a bit of a recap. Well, remember that we had a look at that table. So we had that and look at 2 to the power, 16 to the power of 0, 16 to the power of 1, 16 to the power of 2, 16 to the power of 3. And then obviously we want to be able to know what those decimal values are. So 16 to the power of 0 is 1, 16 to the power of 1 is 16. 16 to the power of 2 is 256, and 16 to the power of 3 is 4096. Okay, so the approach that we go about to determine if what 216 might be in a base 16 number is we first had a look at 4096. Does 4096 go into 216? No, it doesn't. So we place a 0 over there. We then look at 256. Does 256 go into 216? No, it doesn't. So we place a 0 over there. We then look at 16. Does 16 go into 216? Yes, it does. How many times? Well, 216 divided by 16 is equal to 13.5. So it goes in 13 times. Okay, so we have to then say, okay, 216, okay, minus 16, and we're going to get an answer. So that would be 200. Then we're going to subtract again 16. And we're going to get 184. And we're going to keep on doing this, subtracting 16 13 times. Okay? Until we've done it, we're going to do it 13 times. So eventually, we're going to be left with the answer of looking at what 13 times 16 is equal to 208 minus 216. we're going to be continuing with this process until we are left with a value of 8. Okay, so we know it goes in 13 times over there. We're then going to be looking at the next number over there, and we're going to say, well, does 1 go into 8? Yes, it does. How many times? It goes 8 times. So we're going to now be subtracting 1. So every time we're subtracting 16 over here, remember that that is equivalent to 16 to the power of 1. That's equivalent to 16 to the power of 1. That's equal to 16 to the power of 1. Now we're going to be looking at subtracting 16 to the power of 0. And we're going to end up with 7. And we're subtracting again 16 to the power of 0, and we're left with 6. And we can keep on going like that until we get to 0. We're going to essentially do that 8 times. And therefore we can indicate that 1 goes into 8 times. So if we have to now look at that, we cannot represent the number 13. We've got to represent it in an alphabetical number. So there's a little bit of recapping over in terms of the base 16 number system or your hexadecimal number system and doing the conversion. And I'm assuming that you all understand how to do this. So I'm just going very briefly over the basic concept again. Okay, so we remember that A is then equal to a 10, B is equal to 11, C is equal to a 12, D is equal to a 13, E is equal to a 14, and F is equal to a 15. Okay, so as soon as we get the number 13, we can correlate that to being the letter D. Okay, so therefore 216 is equal to a D8 in terms of a hexadecimal number. Okay, so that's all of the steps that we had to take to convert a decimal number to a base 16 or a hexadecimal number. So, or steps we had to take to convert a decimal number into a hexadecimal number or base 16 number. So now that we have to look at a base 32 number, we've got to take into account, what differences would there be in terms of these steps we've got to follow. Well, essentially, we have to look at a table. All that's going to be changing over here is obviously this line of numbers will change. We know that they won't stay constant, but essentially the only difference that is changing is that all these bases are going to become 32s. So 32 to the power of 3, 32 to the power of 2, 32 to the power of 1, and 32 to the power of 0. Also, when we do these calculations, instead of subtracting 16 to the power of 1, we will be now looking at subtracting 32 to the power of 1. And over there, 32 to the power of 1. 32 to the power of 1. When you come to subtracting the numbers over here, it will be 32 to the power of 0. 32 to the power of 0. So we are going to be doing the same process. We're also going to realize that we're going to have some alphabetical letters or characters also in our number system. For example, G will be equal to 16. H, I, J, K, etc. So we have to see how do we go about adapting what we know for base 32 program. Okay, so using the same formatting and style. we're going to have to now implement it. So whenever you see a problem, initially you might not know how to approach it. You might sort of get a bit confused, not know what the initial approach is. Bring it down to something that you're familiar with and try and adapt it from there. So this is like your brainstorming session that we are looking at now. Okay, so this is important for every program that we're going to do. We're going to be looking at brainstorming. So we've brainstormed this, we've looked at how we were going to solve this in our minds. Now let's try and sort of determine some algorithm that will be implemented. Might be some equation we've got to take into account or so. So again, we're going to be looking at a number that needs to be a decimal number that's going to be converted to a base 32. Okay, so what algorithm are we going to have to implement over there? Okay, well, we know we've got this table that we've looked at, and I'm just going to again draw this table over here. So we've got 32 to the power of 0, 32 to the power of 1, 32 to the power of 2, etc. up to 32 to the power of 7. I'm going to say 7 over here. As a matter of fact, let's make this 32 to the power of 6, because that would be actually quite a big number. So I'm using that as a maximum number that we're going to be taking into account. Whenever we solve this problem, what we're going to be doing is we're first going to check, well, does this specific 32 to the power of 6 go into your decimal number? So again, if we look at the number of, let's say, 1016. I want to convert that to a base 32 number. Okay, so the first thing we've got to look at, does 32 to the power of 6 go into 1016? Well, we can see immediately that won't be possible, because it is a massive number. 32 to the power of 16, of 6 is equal to some massive number. It's like 1073741824. So we know it won't be able to go into that. As a matter of fact, to give you an idea, 32 squared is equal to 1024. Just writing this line over here to give you an indication of, in your mind, what the value of those numbers are. So 1024 already doesn't go into that number over there. So we can go through all these columns, check if that number goes into that number. So the first step we're going to have to take into account, move that page over there, is does decimal number go into 32 to the power of n? If not, then n is equal to n minus 1. We need to, every time we go to the next column, we're decrementing the value of n. Okay. If, well, at least, not does the decimal number go into 32 to the power of n, but does 32 to the power of n go into the decimal number? That's more correct. Okay, so then we eventually get, well, if 32 to the power of n does go into the decimal number, then what must be done? We need to then start subtracting (32 to the power of n). And every time we subtract 32 to the power of n, we have to keep a record over there, because that's the value that we're going to be placing over there. So we're going to keep on repeating this loop over here. We're going to keep on checking, does 32 to the power of n go into this decimal number? Yes, it does. So if it does, we need to subtract 32 to the power of n. So therefore your decimal number is equal to decimal number minus 32 to the power of n. But at the same time, we've got to increment some value over here. So we can say some value is going to be incremented every time that we subtract 32 to the power of n. As a matter of fact, we will keep on looping this not only over here, but we'll be going all the way to step 1. Because we need to check also, does 32 to the power of n go into the new value of this decimal? So once we've subtracted 32 to the power of n a few times, eventually we get to the point where we've got to check, well, if it doesn't go through, then we need to say n is equal to n minus 1. Remember, if this is the case, we need to also then say, well, what is the final value for this column? Before we go to the next column, what's the final value of this column? So we need to include over there, what is final value in column? Okay, so we keep on repeating this loop over here. So now example of 1016. Okay, does 1024, 32 to the power of 2 go into 1016? No, it doesn't. Okay, if not, so we'll put a 0 over there, so it doesn't happen, so we need to say n is equal to n minus 1. Okay, 32 to the power of 1, well, that's 32. Does 32 to the power of 1 go into 1016? Yes, it does. 32 does go into 1016. Okay, so now we've got to say, well, it does. So every time we need to subtract 32. So we'll keep on subtracting 32. So we'll be looking at this scenario of 1016 minus 32, which will be 984. But in the meantime, there's some value that we've got to increment. So at the moment, the value would be equal to 0. So now value is equal to 1. Then we subtract again 32 to the power of 1. And we end up with a value of 952. And therefore increment the value of this value again, and it becomes 2. Then we subtract again 32 to the power of 1. And we get an answer of 920. But then again we increment the value of that we've got to keep record to, and that becomes 3. And we keep on doing this. Okay, we keep on doing this process. And you'll find that eventually, if you actually look at how many times 32 goes into 1016, it is 31 times. Okay. So we can indicate over here it goes in 31 times. Okay. Now that we've, sorry, that's not actually what the remainder is. So, minus 1016, there'll be a remainder of 24. And again, we're going to now look, okay, well, does 32 to the power of 1 go into 24? No, it doesn't. So then we'll come back to the step over here in the beginning, and we'll say, okay, well, it doesn't go, so therefore we need to say n is equal to n minus 1. We move across to the next column. Okay, and then we say, okay, well, if that's the case, we need to output obviously what's the final value the final value of that we've been keeping a record. So over here we've indicated that value is equal to 31, but we cannot represent the value 31 exactly as it is. Remember, we need to use some alphabetical letters. So we need to take this into account, but we'll put that on pause just for now. Just finish on with this conversion. Now we're going to be looking at how many times does 32 to the power of 0, in other words 1, going to 24. And we know that's 24 times. So we'll be repeating that process and we will get 24 over there. Okay, so now the problem comes in is that how do we represent this 31 and this 24? Okay, so this is again where the ASCII table is important. As I mentioned to you before, I've got the ASCII table over here. Can you remember when we looked at this ASCII table, I said to you that there were a few letters that were important to be aware of. A, which is the letter 65. We've got to be aware about in terms of the actual numbers. Okay, so for example, 0 is 48. Okay, so, and then 9 is 57. Okay, so what we have to do over here is we've got to take into account a way that we can correlate so that if we get a 10, it will become an A. If we get a 11, it will become a B. All the way up to literally 31. Okay, so we know that the numbers 0 to 19, 0 to 9 is represented by the ASCII of 48 to 56. We also know that the letter A is represented by the number 65. So how can we correlate a 10 to be equal to 65? 11 to be correlated to a 66. If we had a 12 over here, how would we correlate that to be a 67, which will represent your C? Okay, so this is where it becomes where we have to sort of try and identify this correlation, and we've got to try and see how we can correlate it. So if we look at the number 10, okay, if we had to take that 10 and we had to, let's say one of the columns was equal to 10. Now we've got to try and get into letter A. If we had to say, well, we know that A is 65. So if we add 65 to that, what would that be equal to? That would be equal to 75. Okay, that's fine. But if we look at 75 on the ASCII table over here, that's K. We can't do that correlation. But this is taken into account that we haven't considered the numbers from 0 to 9 that are also over there. So if we subtract 10 over here, that will be equal to 65. So if we have an equation where we say, okay, well, if we've got a number n and we add 65 to it and subtract from it 10, that would be equal to probably to the ASCII value correlating into this table. Well, let's give it a try. If we add 12 plus 65 is equal to 77. Okay, so now if we subtract 10 over there, that's it equal to 67. That is that 67 we find over there. Okay, so the thing is you could either say it's n plus 65 minus 10, which I just like that format because it sort of spells it out how we got to that point if we have to make changes later on. You know, it might be that the question needs to be adapted later on a little bit. But other than that, you could also have said n is equal to, or n plus, so let me write it again, n plus 55 is equal to the ASCII value. Okay, so either of those two ways will be plausible. Okay, so in this case, if we look at this example that we now looked at converting, which is 2016, we got one column that's got 31 and one column that's got 24. Can we use the same algorithm to calculate that? Okay, well, we've got 31 plus 65 minus 10. What does that equal to? 31 plus 65 minus 10 is equal to 86. Okay. What's the value of 86 over here? That's a V on the ASCII table. Okay, so that automatically tells us that over here for this 31 will be equal to a V. Let's have a look at 24, because now that 24 also has to be converted. Okay, so 24 plus 65 minus 10. Okay, so that is equal to 79. What's the 79th value on the ASCII table? That's the letter O. Okay, so we know that that 24 is equal to an O over there. So we can comfortably say that 1016 in decimal is equal to VO in base 32. Okay, so now that we've looked at this process we've got to do, we've got now time to put it into some code. Okay, so we've looked at our brainstorming and we've looked at the algorithm. Now we need to try and do this into some draft code, or as I've mentioned before, what's known as pseudocode. Okay, so keep in mind with what we've just looked at, we need to essentially now look at this pseudocode possibilities. Like you do get other methods of planning using flowcharts, like I might have mentioned before. The problem that I find with flowcharts, yes, they can be useful at times, but it can become quite chaotic with having all these lines joining up and things. I find the pseudocode to be easier to follow. Pseudocode is a means of writing out your code. It might have syntax errors in it. So for example, you might be writing an essay and you might want to write it out rough first just to get the storyline first in place. You might have grammatical errors, you might have spelling errors in it, but you couldn't really care about it because you just want to get the flow and layout done first. Once you've done this, then you start wondering about, okay, how does it, what grammar should you use, or what words you should use, whether the spelling is correct or not, and that's what you do in your final sort of version. Okay, so now it comes to this base editor program. What are we going to have to do for this code? Well, again, like I say, pseudocode, we're not too worried about spelling and stuff. Yet, whenever I do it, I try and write it out using the correct code. Mainly for the reason that when it comes to the final writing out, I can almost do a copy and paste of the pseudocode. I don't have to try and think about decoding it. You can write pseudocode straight into the actual code that you want to do. So let's have a look at the pseudocode. So obviously we're going to first have to declare libraries. That's going to be all our hash include files that we're going to have to declare. So we know it's going to be the standard input output file. We know it's going to be the standard lib file that we have to take into account, and we know we also have to include the math file because we've seen that there's some other power that we're looking at. We're looking at 32 to the power of n. So it probably means that we need to have those declared. Okay, then we get to our main program. we need to declare some variables. So the first thing I'm going to be looking at is I'm going to be looking at declaring as integers n, make that equal to 0. Well, n is going to be 32 to the power of n. That's going to be my number I'm going to be keeping track in terms of which column I'm in. I also need to have some value that I'm going to be monitoring and incrementing every time I subtract 32 to the power of n from the input that I've put in. So for that, I'm going to use g. G is going to be what we've used as VAL for value in our sort of brainstorming sessions. I also need to take into account that there's going to be some number that the person is going to have to enter in. And I'm going to call it num. So that's going to be our decimal number that the person is going to be entering in, and we've got to convert this. We'll maybe add more variables over there. We'll see how it goes, and then sort of, populate that as needed. Okay, so now I'm busy doing this draft sort of code, and the main reason is that, especially when you start marking code, or especially if you're trying to have your final code written out or typed out, it just makes it easier, because often you can still do a bit of planning over here and you can manipulate things. You're often able to see some common things that can be joined together, but also it helps out with the marking, so that there's not a whole bunch of little stars that you've indicated, or this needs to be included in a certain line over there or whatever. It's very easy to sort of see, oh well, in your planning, in your draft, you can actually do those manipulations and then write it out neatly in your final code. Okay, so we know we need to have a print statement asking us to enter a number. We know that there needs to be then a scanf command with probably the variable number that we have to take into account. Okay, and you'll see I'm making errors over here. These are commands that I'm using that are legit commands, but the syntax is incorrect over there. These commands will not be executed in a specific way. Okay, so what do I have to do? I've got to try and sort of now get this into a way to do this conversion. Okay, so the first thing I need to take into account is, what is my value of n? What's the first column we're going to be checking and comparing with this num? Well, it's going to be 32 to the power of n. And the maximum value that we've been looking at was 32 to the power of 6. So we actually need to say n is equal to 6 over here. We could also have just indicated n is equal to 6 over here. There's nothing wrong with that. So that could simplify things over there. We just say n is equal to 6 over there when we declare it. Okay, now we've got to take into account, we've got to keep on repeating and looking at certain tasks happening. And if you look at your table, we kept on repeating this task of subtracting n and going to the next column until what condition became true? Until n was, or that was, we kept on looking at all of this and up to the point where n was larger than or equal to 0. Okay, so we need to have some other loop system over here. And it is up to n is larger than or equal to 0. That's what we need to take into account. Okay, so that's some loop system we're looking over there. And now we need to check, okay, well, we can keep on looking at this. We'll come back to this because we know we're going to have to move through each column as we go along. But what we're going to be doing now is we've got to look at each specific column and see if that number is able to go into the number that's been entered by the user. Okay, so the users enter in the number num. Okay, so if num is larger than or equal to 32 to the power of n, then we know, well, we need to start deducting 32 to the power of n from num. Okay. So, therefore, we know that that's going to mean, if that's true, we need to say that num is equal to num minus 32 to the power of n. Okay. Keeping in mind, every time we deducted 30 to the power of n, it meant we needed to increment a value. And we indicate that is our g variable that we're going to be looking at. So therefore g is equal to g plus 1. So this has to happen every time num is larger than 32 to the power of n. Okay, now as we keep on deducting the 32 to the power of n from num, we're eventually going to get to the point where this is not valid anymore. We're not able to deduct 32 to the power of n from num, which means we need to then therefore move to the next column. Okay, so that would be this else statement over here. And what would be required with this else statement? These arrows are just for me to keep in line of what each section is, that just for me in my mind. You know, you can put those arrows there, you don't have to put those arrows there. It's all got to do with your own personality and how you want to solve things. Okay, so if 32 to the power of n is not able to go into num, that means it's that now we have in num to be less than 32 to the power of n. We need to then say n is equal to n minus 1. So we need to deduct n, but at the same time we need to now go and output the value that we've been counting over here, the value of g. So we need to printf the value of g. But we know that we're going to have to add 65 and subtract 10, like we did in the calculations before. So we've got to do that. So that's got to be printed out. And then at the same time, does it always have to happen though? I mean, let's say g is equal to 3. Do we have to add 65 and subtract 10? You don't, because it's only if g is equal to 10 or larger. Then we've got to go into alphabetical letters. So we need to look at this over here. We say, okay, well, wait a minute. And I'll make a little star over there and a star over there. This is only if g is actually larger than 9. If g should be less than or equal to 9, we do not need to add this over here. So we need to take that into account over there. Okay. So if that's the case, we need to print this. So if this is not the case, if g is less than or equal to 9, we can then have another else statement over here for that if statement that was just placed over there, that needs to say, okay, just print f g. Printf g. Okay, so keep in mind, when this printf statement is happening, we've got to consider g to be as a character. So in other words, if we want to print the ASCII value of it, we actually need to use the command printf %c comma 65 plus g minus 10. Okay, so this over here, this is just my little bit of rough sort of notes that I've got to make. This is a command I'm going to actually be using. That's just what I've got to keep in mind over there. At the same time, when I printf this g over here, in other words, when g is less than or equal to 9, I actually just need to, g needs to be an integer. I can just print it as an integer. So in other words, it will probably be something like printf %d of the letter g, or the variable g. Okay, so again, this is just a side note that I'm making that I need to keep into account when I'm doing this. Okay. Is there anything else I'm missing out over there? It might not look at the moment like there is anything that I'm missing out. And it's probably only once you start going through the code and you realize, oh wow, there might be something going on. And we'll actually do that. We'll go through this step by step and see if there's anything we've missed out. Okay, so after we've done that, we will essentially end this else statement. We'll end this if statement, end this loop. And then we might want to have some return 0. This is our basic program we've got to look at. What else do we have to take into account over here? Well, one thing that I'm just recognizing over here is that we cannot check 32 to the power of n. That's not a valid command. So again, I'm making a note over here and saying, well, listen here, keep in mind that you probably have to use a power of 32, n over there. If I use power 32, n, do I have to take into account a floating number? If it was that 32 to the power of n was assigned to a specific number, then yes, you would have to take into account that a floating number is going to be used because this is an output. You can compare a decimal number to a floating number in terms of its actual value, in terms of is it larger than or equal to. But you do not need to necessarily go and assign some num to be, for example, a floating number. Okay, so now that after we've done this, the next step we've got to do is we've got to check our code. Check if everything's valid. Okay, and for this I'm placing a piece of paper next to it. And what you would generally probably do when you're brainstorming these type of problems, or when you're doing a test exam scenario, at least that's what I normally do, is I draw sort of a line on the right hand side, sort of as a margin, and try and keep track of the variables that I've got over there. So what I do is I normally say, okay, well, we know that n is equal to 6 over there, we've declared it over there, we know that g is equal to 0, and we know num is equal to 0. We ask the user to enter a number. Now it's got to scan f of a number, so that means a new number has been entered. So that's going to override this num value over here. So we now know that num is equal to 1016, as we did in our specific example. Okay, now we're going to start looking at this. We've got to have a loop over there. Okay, so what loop have we looked at where it will keep on looping until some condition becomes true? We don't know how many times it's got to happen, but it's going to keep on doing until condition is true. Remember, that was a while loop, so we can actually put in over here, it's probably going to be something like a while loop, because we know that this has to keep on going until n is larger than or equal to 0. Okay, so is n larger than or equal to 0? Well, n is equal to 6, which is larger than 0, so we come and check the next line. Is the number 1016 larger than or equal to 32 to the power of n? Okay, so 32 to the power of 6 is a large number, and we have seen that that doesn't happen, so therefore this if statement is not going to be executed. We go into the else, n is equal to n minus 1, so now n is equal to 5, and then it's going to check, well, is g larger than 9? Well, g is equal to 0. Okay, so we don't need to worry about that. So it's going to print out, to the out statement, it's going to print out the value of g, so therefore the output, we can have like an output screen over here. And we can indicate that that is just a 0. Okay. As a matter of fact, because we can't sort of see it over there, I'm just going to have over here maybe output. I'll call this my screen. It's going to be a 0. Okay, now we know that there's some loop happenings. Comes back to the while loop over there. Right, so let's look at that now. So we keep on repeating, n, is it larger than or equal to 0? Well, at the moment, n is equal to 5. So yes, that is valid. Okay. Is num larger than 32 to the power of n? Well, now we've got 32 to the power of 5 is still a larger number. Remember, we only realized that when we did the calculation that up to 32 to the power of 1 was valid. So we can say, yes, we know that's not true. Therefore, this is skipped. So therefore, n is going to decrease, and now n is going to be equal to 4. We know that it's not going to be printing out this number because g is still equal to 0. And with g equal to 0, we know that we don't have to worry about this conversion. So it will still print out a 0. Okay, so we can sort of fast track this and keep on going through this, and we will realize n will be equal to 3, which will be printing a 0. N will be equal to 2, which will print in a 0. N will be equal to 1. We can't print out a 0 yet. We first got to check it. Okay, so n is larger than or equal to 0. Correct. Okay. Is the number larger than or equal to 32 to the power of n? So 32 to the power of 1, which is 32. Yes, it is. Okay, so now we need to say, okay, number is equal to number minus 32 to the power of n. So now number is equal to 1016 minus 32. Okay, so that is 984. And g is equal to g plus 1. So now suddenly g is equal to 1. Okay, so this our statement is going to be ignored because this if statement was executed. Go back to the beginning of the loop. Is n larger than or equal to 0? Yes, it is still. N is equal to 1. Okay. So I was going to check and say, okay, well, is the number 984 larger than or equal to 32 to the power of 1? Yes, it is. So now num is going to be subtracting 32 to the power of 1, which is going to be equal to 952, and therefore g is equal to 2. Let's go again, and it's going to repeat the same process. Eventually num is going to be equal to 920, and g will be equal to 3. And you're going to keep on going with this process over and over. Eventually you're going to find that num, and I mean, it might be a good exercise for you just to go through the whole process to check your code, because it's important to make sure your code is all working. Eventually num is going to be equal to 24, and g is going to be equal to 31. Okay, now it comes back over here. N is still larger than or equal to 0. So we will continue with this loop. Is num larger than or equal to, in other words, is 24 larger than or equal to 32 to the power of 1? No, it's not. Okay, so therefore this statement over here for the if statement is going to be ignored. It goes automatically to the else part of the statement. Okay, so now n is equal to n minus 1. So therefore n is equal to 0. Is g larger than 9? Yes, it is. G is 31. Okay, so now it's going to have to printf this. So it's 31 plus 65 minus 10, which will then print out the character correlating with that. In this case, it was a V. So on our output, we will see a V. Okay. What about, well, this else statement over here would be ignored, so therefore we go back to the beginning of the loop. Is n larger than or equal to 0? Yes, it is. N is equal to 0, so it will keep on still looping us. So only when this n minus 1 makes n equal to minus 1, then it will stop this whole loop. Okay, is the number 24 larger than 32 to the power of 0? In other words, larger than 1? Yes, it is. So therefore num is equal to num minus 32. So now num is equal to 23. G is equal to G plus 1. So therefore G is equal to 32. Wait a minute. Is this right? We can't go and sort of say G is equal to 32 over there. That's now adding up to the previous column of numbers. We've already dealt with that. That's a V over there. G should now be equal to actually in reality 1, not 32. We should have resetted G to 0 over there. So every time we print out a number, we need to reset G. So over here as part of this else statement, we need to also say, well, G is equal to 0. So in that way we're resetting the value of G. So then G would have automatically have been equal to 0 over there. So now when we add 1 to G, it would automatically say that G is equal to 1. Okay, so this you'll see over here, that's where it's crucial to go through your planning and your code line by line to monitor the values and see if you're able to get a correct value as in the example that you're sort of looking at. Okay, let's keep on going. Back to the beginning. Is n larger than or equal to 0? Yes, it is. Okay, is num larger than 32 to the power of 0? Yes, it is. So now we can say, well, num is equal to num minus 1, so now num is equal to 22. And therefore G is equal to 2. And again, you can keep on going with this process. Eventually, you're going to find that num is equal to 0 and G is equal to 24. Okay. So now again we come to the top over here. Is n larger than or equal to 0? Yes, it is. So we can go into the loop. Is the value of num, which is now 0, larger than or equal to 1? No, it's not. So now num is equal to, so this part of the if statement will be ignored. It will come to the else statement. So now n is equal to n minus 1. So now n is equal to minus 1. Is G larger than 9? Yes, it is. It's 24. Okay, so now it's going to say 24 plus 65 minus 10 and print that character. So we know that that is an O. And it's going to ignore this else part of the statement because this if part of the statement was executed. G is now going to be equal to 0 to reset it for the next column should we have to look at that. Again, we're going to look to the top. Is n larger than or equal to 0? Well, wait a minute, n is equal to minus 1. So this condition is not true anymore. So now, but we've actually done all the calculations. Now num is equal to 0, so we don't need to do more calculations. We are in our final column. So now it's going to exit this loop and come to the bottom and then continue with the code, which returns 0. Okay, so looking at this, it seems like our code is now working. Like I mentioned, we're going to have to just look in terms of the spell 32, n to be replaced over there. We're going to have to look at printing out this character over there for numbers that are larger than 10. And in cases where g is less than or equal to 9, we can just print out that actual value as a normal decimal number. So it seems like our code is working. There is a chance that there could be errors, but it's very slim. We've gone through it, we've tested it, we've gone through pseudocode, we've actually done a testing over here, which is one of the steps you've got to always do. Okay, so we know that is working. So we can be almost comfortable we've got the right code over here. Now if you look at this, we spent probably about an hour not even looking at any code at all. All that we've done is we've spent looking at brainstorming. After we've brainstormed, the second step was to do an algorithm, so see what steps and process we had to follow. After we did the algorithms, we started looking at the pseudocode, and we did a very rough sketch of how our code is going to flow and appear. After we did this, we started looking at the testing, and we actually went step by step through the code. And I mean, we could have actually spent a little bit more time to test this code. You probably could have found that you could have spent another 15 minutes going through every step for every number that you take into account over there, which is fine if you need to do that. So we've done 4 steps up to now, not even looking at any code, not looking at typing anything out yet, just in terms of how we're going to solve it. Okay, so now now that we know that this code has got a very good chance of actually working, we're going to now convert this onto the actual computer. And that's what we're going to be doing next. So we're just going to keep on referring to this, and we're going to interpret what we've got over here into our code that we've done, and we will then run a code and see if the code operates as we expect it to be. Okay, so my advice is, with the pseudocode that we've generated so far, try and create the program yourself. You know what steps have to be followed, so type out the code yourself, and then once you have done it and you've tried the program, see if it's running, then maybe continue with this video clip. But we're going to be now essentially looking at transferring what we've done in the pseudocode into CH, and then see how it responds. Okay, so the first thing we looked at was declaring libraries. So we had to, therefore we've got to have hash include. We looked at the standard input output.h library. We need the hash include it was the standard lib library, and then also hash include math.h library. So those libraries were declared. We then went into our main program. So it was int main void, and we've got our curly brackets over there. Remember, the last command for a program is return 0, so we can place that already in there. And then the last thing we need to look at in terms of getting our basic format of how the code is laid out is the declaration of the variable. So we've got int n is equal to 6, we had g equal to 0, and we've got num equal to 0. So those were the three variables we declared in our pseudocode. Alright, we also had a printf statement. And we're going to say enter number to convert to base 32 number system. And therefore we also need then a scanf command, which will be a %d, this is the integer that we're inputting, comma, and then also remember ampersand num. Okay, so we've done that. Then we said that once we've done that, we need to now say we need to have some loop, and we indicated that it's a while loop because we don't know how many times exactly it's got to happen. For every specific case that we are going to be looking at, is going to be different amount of times it's got to run through it. So we've got a while loop. Okay, and the condition for the while loop was going to be n needs to be larger than or equal to 0. Now you'll see I'm trying to correct things in terms of just spacing and stuff to make it neater. It always helps to have to follow the code when it's neater than having to try and figure out where you are. Okay, so while we've got a while loop over there, I then say, okay, well, the first thing we need to check is if the number is larger than or equal to 32 to the power of n. Okay, so if num is larger than or equal to POW of 32, n, like that. And if that's the case, then we say that that num is equal to num minus 32 to the power of n, and we said g is equal to g plus 1. Yes, I could have said over here just g plus plus, as that would have also been an acceptable way of incrementing the value of g. I'm keeping it to plus 1 over here because, you know, if you want to look at maybe other programs that might be similar, there might be times you want to say g plus 2. So I'm just trying to keep it in the same format should it be needed later on for other type of calculations or problems we need to solve. Okay, so that if statement is taken into account. We also indicated there was an else statement we need to take into account. Okay, so else, we indicated that there must be n is equal to n minus 1. We saw that we needed to check if g was larger than 9 to print it out. So therefore, if g should be larger than 9, you'll see I'm always opening the brackets and closing the brackets for each segment together to make sure all my pieces of code are lined up and also neatly laid out and together so we don't get confused between code. Okay, so if g is larger than 9, then it must just say printf, and we said that it needs to be a character, so we're going to have a %c, and that's going to be 65 plus g minus 10. Okay. We also indicated that in our pseudocode that there must be an else statement over here, which is specifically for a scenario should there be, or should g be less than or equal to 9, and that would just need to be printing out a number, that specific number correlating to g. Okay, so we've got percentage D over there, comma G. Okay. And then lastly, the last thing we said we needed to make sure it's done as part of this code under this else is we need to say G is equal to 0. We need to reset G whenever we go to the next column. Okay, so after we've done this, I think all that I'm going to do over here, just for trying to sort of make things a little bit more neater, add a few lines over there, like that. Right, save this, let's see if it runs. Okay, syntax error. Oh, standard lib.h, I misspelled that, so I can rectify that. Let's run it again. Another, hash include I misspelled over there, so I can rectify that. Let's try again. Another syntax error. Oh, and forgot about a semicolon for n is equal to n minus 1, so I can place a semicolon over there. Try again. Okay, enter num to convert to basically to num system. But before I do that, I'm going to stop it. I'm just going to place a colon and a space over there so that it's neater for me to put in a number. Okay, so I'm going to run it. Let's try the number. Number that we looked at was 1016. And there we go. The output is VO. So that seems to be working. Let's try just another number. So I'm going to say 999. And that's equal to V7 in a base 32 number. Okay. Let's make it a massive number just for the fun of it and see how it turns out to be. So 938572740. Let's see what happens to that. 0RV2UU4. Okay, so it seems our code is working. The test examples we did shows that it is working. So we are quite confident we've typed out the code correctly. We're quite confident that we've done the code correctly. There's no deviation in terms of our test for the different variables and how they verified compared to what we did in the code. And so if you were able to generate this code before looking at this video and get it working, well done. That's a very good sort of step forward. If not, do not worry. Like I said, practice makes perfect. You need to keep on practicing. It's the only way you're going to improve and actually get things to work and find errors. You will also find that there's a lot of syntax errors that get made as you type things out, and you don't do it necessarily on purpose, but it does happen that one does do it, and you just have to correct it when needed. Okay, so we basically looked at the 5 different steps we've got to do. Yet we've got one more thing we need to keep in mind. So now that we've typed out the complete code, we actually need to start putting in comments. We need to clarify in terms of what are we doing. So you could probably start off at the base with a comment of this program converts a decimal number to a base 32 number. Okay, like that. So that gives you a bit of a description of the program. You might want to have a comment over there such as declaring the libraries. So we're just saying what we're doing for different sections. So obviously when you write out your code, you need to make sure that there's space, or you need to add these comments as you write your final code. Okay, so we've declared the program over there. Int main word, we know that is our our main program. Over here for the integers, we're going to just make a comment over there saying n refers to the column slash 32 to the power of n value in the conversion process. You might want to just add over there another comment and say G refers to the counting of the number of times that 32 to the power of n goes into num, and we want to also maybe just indicate over there that num is the decimal number that the user will input. Okay, so now if a programmer had to come and look at your code and say you see you declaring n, g, and num, they will already get sort of a picture of what n, g, and num are referring to. Okay, so we've got printf enter num to convert to basically to number system. That makes sense. We've got a scanf over there, which we know is now some input that the user puts in. Now it comes to the while loop, and it might be worthwhile to mention over there, just in terms of why we have this while loop. So we want to repeat going through every column from 32 to the power of 6 up to 32 to the power of, or down to 32 to the power of 0. Actually, that reminds me, I'm just checking over here something. Okay, we did do that. Alright, so again, I'm just checking over here that we definitely make sure that n was equal to 6. It might have been a good thing for us to maybe just say over here at the bottom n is equal to 6. Something should go wrong in the code, some memory corruption, and it just needs to be reassigned over there. We could say n is equal to 6, even though we indicated initially equal to 0 over there. You could do that. And the reason being, especially if you've got large bits of code and you've got a limited process and it's busy crunching out these numbers, and there might be some numbers in memory that could be become corrupt in the meantime. If it's to do with a constant, you might just want to reaffirm what it is. Okay, so we want to go through every column from 32 to the power of 6 down to 32 to the power of 0. So that's the reason for the while loop. So i.e. the while loop. Okay, then we're going to check over here. Okay, so essentially we're going to say, well, if the number, or if 32 to the power of n, of n, is able to go into num, then 32 to the power of n must be deducted from num, and g must be incremented. Okay, then we can indicate over there G is to keep track of the number of times that 32 to the power of n is going into a specific number. Okay, so we sort of explained over here what we're trying to do. We could actually go and place this comment on the next line over there. So it's explained to us what we're going to be doing over here in this if statement. Okay. Otherwise, if this is not should this not happen, n is equal to n minus 1. So we are moving one column to the right. Okay. If g is larger than 9, okay, so no conversion into alphabetical characters needed. Well, sorry, it needs to, so actually conversion into alphabetical characters are needed. Okay, so this is what it does over here. So therefore, just explanation of that, that calculation, we've got 65 in ASCII is the letter A, added to the value of G, and subtracting 10 for characters 0 to 9 to be accommodated. Okay, so that just gives us a bit of a breakdown of why we got 65 plus G minus 10. Okay, otherwise we can say over here, no conversion is needed for numbers less than and equal to 9. Right, and we need to make a comment over here for G. So G is reset whenever moving to the next column. Okay, so over here I'm just saying printing a bunch of new lines for appearance purposes and return 0 0 is returned because the program executed successfully. Okay. So we've made some comments over here, and that's the last step that we need to take into account when writing a program. So essentially there's a few things we need to just recap. Whenever you get a problem, the first thing you do is you brainstorm about it. How are you going to solve it? How do you solve it in your mind? And jot it down onto a piece of paper. Then we need to identify these ways that we looked at into solving the problem. How do we place it into an algorithm? Can we let it correlate into something similar? So then we develop the algorithm. Once we've done the algorithm, we look at the pseudocode. The pseudocode would be a rough sort of layout of the code. Keep in mind there could be syntax errors or so, but it's our scribbling around to try and figure out how we're going to solve this code. Essentially placing that algorithm that we've just looked at into some form of code that we can follow. After we've done that, we test the code. So we actually keep track of the variables on the right hand side, in the margin or so, or could be on the following page, and we go through the code and make sure that the numbers are actually what they indicate they should be, and what every time we assign a new value to it. If that seems to be all running fine and our sequence of our code seems to be correct, then we can be happy to say, well, we know the code is running. The next thing we need to do is then to transfer that pseudocode into our final code. We will write it over all neatly, and we'll add the comments to it. Okay, so these are the different steps that you follow to solve a problem from the start to the end. You will notice that the typing of the or writing of the final code in the comments was probably about 15 minutes of the time, and so most of the time gets used in terms of the planning, in terms of the looking at the algorithms, brainstorming the problem, and trying to get behind the issue and how you're going to solve it. So if you follow those steps, you should be fine for any type of program that you come across. Okay, so this is a good example to prepare you to help you to also prepare for tests and exams in terms of how you should approach these problems. And it doesn't matter what problem you get, you'll always follow these same steps.